Hello, good afternoon. So today we are going to discuss some problems or numericals regarding the star delta transformation. Star delta transformation is very important for our university examination. Okay, so we have to give due importance. So with this star delta transformation, we are finishing first half portion of our module 1. Okay, so as usual, you have to give your attendance. So click on mark your presence in your Google slide and you can submit your attendance. So in this class, first I will give the summary of last class star delta transformation, that is equations, and then we will move on to solve some problems. The problems will be around 10 problems I will discuss. So let's start with the summary. So first I'm going to discuss on delta to star conversion. So first we have to check is we have to make sure that we follow the same equation pattern. That first for delta connection I use RAB, RBC, RCA. Okay, I use the resistance with the two suffix letters. So RAB, RBC and RCA corresponds to the resistances in the delta connected circuit, while RA, RB and RC are the corresponding star connected resistors. Okay, for delta we are using resistance with the two suffix letters, that is RAB, RBC, RCA, and for star connection we are using letter with only one suffix, that is RA, RB, RC, and the common point we can denote it as 0 or practically we denote it as N for neutral. Okay, so first I am going to discuss on star uh, First, I am going to discuss on delta to star transformation. So, in a delta connection, we were given the delta values. What are the delta values? That is RAB, RBC and RCA. RAB, RBC and RCA are the given values and we have to convert it to find out RA, RB and RC. How can I find out RA, RB and RC? That is, in order to convert to any star connection, we have to find the product of the adjacent sides divided by sum of the arms. Okay, so first I'm going to discuss on this RC. So what is the adjacent side? That is the sides which are connected to C, that is CA and RBC. So in order to find out this equivalent resistance RC, we have to find the product of RCA and RBC divided by sum of all the resistances, that is RAB plus RBC plus RCA. Okay, now what we have to do is we will try to check on RA. How will we find out the resistance RA? So in order to find out the resistance RA, what we have to do is we have to find the product of the adjacent sides, that is RA. Adjacent sides are RCA and RAB, that is adjacent sides always touches this point A. So we can select all the resistances with the suffix letters A. So I am selecting RCA and RAB divided by RAB plus RBC plus RCA. Similarly, for RB also, what is the RB? RB is equal to product of RAB and RBC divided by RAB plus RBC plus RCA. If we look very carefully, we can see all the denominator terms are always same. That is, while converting delta to star, all the denominator terms are same only. Okay. And in the numerator term, uh, that will be the product of the adjacent sides. Okay, we will solve problem, don't worry. Okay, so this is how we will convert delta to star connection. Now we have to convert star to delta connection. How will we convert star to delta connection? While converting star to delta connection, we will be given the star connection values. Okay, the resistance values in star connection. What are the resistance values? RA, RB and RC are the given parameters and we have to find out RAB, RBC and RCA, that is delta connected resistances with the RAB, RBC and RCA we have to find out. Okay. So for that, what we will do is we will find the ratio of sum of combinations. What are combinations? I am having A, B, C resistances. So the combination is, first combination is RA, RB. Then I can select RB, RC. Then I can select RC, RA. So these are the three combinations. So in order to calculate or in order to convert star to delta transformation, we have to take the ratio of sum of the combinations divided by the opposite branch. Okay, so here if I am first I am considering RAB. When I am considering RAB, what are the sum of combinations? That is RA plus RARB plus RBRC plus RCRA divided by the opposite one. That is, we have to find out RAB, isn't it? So the opposite one is RC. Here we have to find out RAB. So the opposite point is RC. So we have to divide it with RC. Okay. Or if you find it out very confusing to find out the identify the opposite branch, then what you have to think is other than RAB. So other than A and B, we are having only C. മനസ്സിലായോ? ഇതിനകത്ത് ഓപ്പോസിറ്റ് ബ്രാഞ്ച് എന്നൊക്കെ പറയുമ്പോൾ ചിലപ്പോൾ കണ്ടുപിടിക്കാൻ ബുദ്ധിമുട്ടുണ്ട്. എന്ത് ചെയ്യണം എന്നറിയാവോ? RAB ആണ് കണ്ടുപിടിക്കേണ്ടത്. അപ്പോൾ എയ്ക്കകത്തും ബിക്കകത്തും ഇല്ലാത്തത് ഏതാണ്? സി ആണ്. സോ ഡിവൈഡഡ് ബൈ RC. Similarly, if I have to find out RBC, then I have to take RARB plus RBRC plus RARC divided by, we have to find out RBC. So divided by RA. B യിലും C യിലും ഇല്ലാത്തത് A ആണ്. So divided by RA. Similarly, we can find out RCA also. So in order to convert star to delta, then we have to find the sum of the combinations divided by the opposite branch of star connection. Okay, now we will move on to our problems. We are going to solve some problems. There will be 10 problems. So first question is, we have to find out the star delta transformation. Using star delta transformation, we have to find out the resistance between A and B. So while I have already shared the slides, so what you have to do is you have to pause here and you have to solve for this question. Okay, the slides are already shared to you, so pause here and you have to solve for your question. So while solving, you will get 3.84. If your answer is correct, then you can move on to the next question. Click here for the next question. If your answer is not this, then please click hint so that you will get a detailed solution. So I am going to the detailed solution for the first case. So what I am going to do is, here this is the circuit. So I have a delta connection here. I have a delta connection here. This is 524 is a delta connection. 532 is a delta connection. Okay, so I can solve any of this. So first what I am going to do is I am going to choose the first delta connection. This is the first delta connection. So I am converting this delta to star. So I have redrawn the same circuit such that this is a delta connection and I am converting it into the star connection. So how will I convert delta to star? In order to find out this R2, we have to multiply the adjacent sides. That is 5 into 2, that is 10. 10 divided by sum of the resistances. Sum of the resistance means this much resistances sum, that is 5 plus 3 plus 2. Okay, so R2 is equal to 5 into 2, that is 10, divided by 5 plus 3 plus 2, that is 10. So R2 value should be equal to 1. Shall we check the answer? So here look, R2 value is 1. Similarly, we have to find out this R3. What is R3? R3, we have to find the product of adjacent sides, that is 5 into 3, that is 15. 15 divided by 5 plus 3 plus 2 is 10. 15 divided by 10 is 1.5. See, R3 value is 1.5. And next what you have to do is you have to find out R1. How can we find out R1? This is R1. So product of the adjacent sides is 3 into 2, 6 divided by 10 is 0.6. Okay, so we have found out R1, R2, R3. Now we have to redraw the circuit. While redrawing the circuit, we have to omit this one, this 3 ohm and this 2 ohm, and we have to draw this star connection alone. So I am drawing the star connection here, and I have removed all the delta connected branches here. There was a delta connection here, I have removed it. Okay, so now I am substituting the values, and here we know that this R1 and 5 are in series, this R3 and 6 are in series. Okay,